All right, here we go, guys. Just a quick run through of these warm-up questions. The first one says find the complement. So to get the complement, you're going to do 90 minus the angle, whatever the angle is. Complements have to add up to 90. So if that's 60 degrees, 90 minus 60. If that's 70 degrees, 90 minus 70. Right? 90 minus 60, 90 minus 70. And if that is x degrees, 90 minus x. Boom, shakalaka, killing it, loving it, there it is. The complement of an angle, quick recap. We're going to say x is our angle. Actually, let me do it like this. If we have angle, we have complement, and we have supplement. Remember, the angle is unknown. We call it x. Well, if x is the angle, the complement is 90 minus the angle, just like we just did. And the supplement is 180 minus the angle. So in these problems, when you see these key words, we're going to replace them with their translation, as we called it. So the complement of an angle would be 90 minus x. Is equals 10 less than is something minus 10, half the supplement, half the supplement. The supplement of an angle, if we don't know the angle, the supplement is 180 minus x. So let's look at this real quick, right? Let's get this down. The complement of an angle, complement of the angle, is 10 less than means something minus 10, half the supplement, half of a supplement. We translated this verbatim exactly what they told us. So if I was working on this, the first thing I would do is distribute that 1/2. And then you don't have to do this next, but I'm going to double everything. And that's going to get rid of my fraction. So it's kind of like we're going in circles a little bit, but yes, I mean, it is what it is. So we double everything to get rid of that 1/2. So 180 and then minus 20. We double every number. All right. Now get our x's on one side. Add 2x would be positive x. This is 160 minus 160 would be 20. So I added 2x. I subtracted 160. X is 20. So x equals 20, the complement equals 70, and the supplement equals 160. Find all three of those things. Those are my answers. Find distance and midpoint. Distance is the square root of, and we ask ourselves how far apart. How far apart are those numbers? 7, we square it. Remember, distance is built on Pythagorean theorem. So this is delta x, that's left and right. This is delta y, that's up and down, and this is our distance. It is delta x squared, the distance between the x's squared, plus delta y squared. Take the square root of that, and you have your distance. Well, what is delta y? How far apart are those numbers? That's right, they are 10 apart. So this is going to be the square root of 149, and you can just leave it like that unless they ask you to round. Then we have midpoint. Midpoint is the average. We're going to add the x's, divide by 2. We're going to add the y's, divide by 2. It is an average. So to get the midpoint, we're going to add 3 plus negative 4. Do we write it like that? No. What is 3 plus negative 4? It's 3 minus 4. Negative 10 plus negative 20. And it'll look like that. So that's negative 1/2, comma, negative 30 divided by 2 would be negative 15. And there's my midpoint. B is the midpoint. Let me look at that again real quick. Make sure you can see it. Everyone sees it. There's our answers. Everyone sees it. Okay. B is the midpoint of AC. So this time they're saying B is the midpoint. So negative 3 comma 5 is A. 12 comma negative 15 is B. I like to stack them, and we're looking for C The way I like to do this is figure out how do we travel. -3 to 12 is plus 15. So if we add another 15, we land at 27. 5 to -15 is minus 20. So if we do another minus 20, we land at -35. If we do midpoint, we can check our work. Like, what is this plus this? That would be 24. Divided by 2, nailed it. What is 5 plus -30? That would be -35. That'd be -30 divided by 2. That's -15. Nailed it. So you can check your work by working backwards. Find Q, 3/5 the distance from A to B. This is much tougher. So we have steps here. So we're going to work on the x's first. Let me rewrite my coordinates, A and B. So A is -3, 5. And B is at 12, -15. And we're going 3/5 the distance. So the steps never change, but you have to understand what you're doing. So if we're trying to find the x coordinate, I'm going to work on the x coordinate. We need delta x first. So we're starting at A, we're landing at B. That's going to be plus 15. So plus 15 matters. Remember, the only time we don't care about plus or minus is when we're doing distance. So here we just kept them positive the whole time. But in every other case, we do care if they're positive or negative, including now. So it's positive 15, that matters. And then we are going to take that number, 15, that's the distance between the x's, and we're going to make our adjustment. Our adjustment is 3/5. So we're going to multiply it by 3/5. It's how far apart are they times our scale factor. And the way I want you reading this, I showed you this in class, but read this as 15 divided by 5 times 3. That's the best way to read this, and that's going to be 9. Right? 15 divided by 5 is 3. 3 times 3 is 9. And then finally, that's the distance to the point, but we're starting at -3. Your last section is your starting x plus your distance. So that's going to be -3, our starting position, plus 9 is going to land us at 6. So my x coordinate is going to be 6. And then over here, do the same thing to the y values. So to find my new y value, I need to know the delta y, and that is -20, right? 5 to -15 is -20, and we're going to hit that with the scale factor 3/5. How are we going to read that? We're going to divide by 5 first. That's 4, and that's going to be -12. So if the entire distance is going down 20, 3/5 of that would be going down 12. -12 is not the answer. -12 is the distance to the answer. We're going to take our y1 value and we're going to apply the adjusted distance. And there's my answer. Boom. That's the hardest one here. We can keep working on this together. You can ask questions in class. But boom, got it. Love it. I'll see you guys soon.